Well, hello everyone, and thank you for joining the call. My name is Mohit, and I run this user group to um, to uh, to enable cybersecurity and everything around it, the awareness around it. Um, I am a chief consultant at Atea, which is a Norwegian firm. I've been there for a couple of years, and my interest is mostly cybersecurity, cloud interfaces, cloud operations, and recently artificial intelligence and the large language models, generative AI to be very precise. Okay, cool. We'll just wait a couple of minutes, just one more minute to see if there's anybody else who's going to join in, then we start off. I guess we'll start off now. Okay, well, in case you have anything that you want to share, make sure that you put it on the chat and we can go through it at the end of it. And if in case you have something that you want to share on the user group and you want to talk about regarding cybersecurity or anything around it, more than happy to accept a session and organize a meetup dedicated to that. Cool. Now that we have the obligations out of the way, the session. The session is mostly about starting a series that deals with the intersection of cybersecurity and the large language models, both of which have been really hot as in technology right now. And the number of cybersecurity incidents based on these recent AI markups have been increasing and becoming more sophisticated. And that's the reason it was worth to explore this session a little bit more. Now, the reason why I have this session here is because in the start of 2024, there was a very interesting attack on a Hong Kong-based firm, which actually cost them around $25 million. This was a phishing attack, but it was not a normal phishing attack. It was very sophisticated and used AI to a very deep extent. Now, the story starts on January 2024 when an employee in a Hong Kong firm gets an email asking him to transfer a couple of $1 million to a couple of different accounts. Seems like an ordinary email, but what happens eventually is that this email is followed by a meeting invite from co-workers and his managers and a very senior executives that were there facing him on a live call, talking to him and asking him to go ahead and authorize the transaction. This employee, obviously perplexed by the whole situation, did not attempt to question it because that's normally a situation that's not heard of. Mostly people get phishing emails and they have ordinary typos, or the email is probably wrong, something that's an obvious giveaway. But this did not have that. This had a proper wording in a way that the person whom it was asking that the email is for, the format of the email, the writing style was exactly identical. And on top of that, the email gave a Teams meeting link. The meeting actually had people staring at him from the camera, which was unheard of at this point of time. Now, because there was a deepfake meeting, which this employee did not realize, because unlike most of the people who are involved in the computer industry, a large portion of employees in a company do not interact with computers in the way we do. And that's why this was something that they could not realize. They could not realize that this might be a meeting that the person who's sitting in front of him might not be the same person. He did not cross-check, and eventually, during the day, the person authorizes a transaction of around $25 million to many different accounts. The moment they do it, the hackers, they siphon the money, transfer it to anonymous accounts and bitcoins and stuff, and the money is just gone. This was a huge breaking news because this was the first time a major hacking attempt happened in which the generative AI, the capabilities of designing and swapping faces and writing emails with such dexterity were used. And this opened up the Pandora's box. This this was the GitHub repository that was used to create the video around it, and at least the investigations around it. This GitHub repository is available live, can be downloaded, can be used to go ahead and create deepfakes for people actually live on video calls. So right now, this person who's demonstrating it has made a live video call for Elon Musk, which is pretty exciting. We all know Elon Musk doesn't do live calls like that, so it's kind of a giveaway. But in case these technologies are used and they only need a couple of pictures, most recent papers that have been published around these, they only need one good picture with good lighting, and that's all. 3 second worth of audio clips, and then you're just copied. That is the possibility. That genie is now out of the bottle because ChatGPT, when it released, it unleashed a technology that is only getting wilder with every year. The technology like Midjourney, the companies like Midjourney, OpenAI, and Google's Gemini are making sure that these models are trained and more available, more sophisticated with every year that goes by. Thanks to open source, these models are available to general public now. So if you have enough knowledge, which is very less comparatively, it's possible to run these models on your computer, sometimes without even GPUs. That's scary, and that's an opportunity in itself. And that's one of the reasons why I am trying to have this talk, to understand and demonstrate what I have learned around what are the possibilities for it. Now, before I move forward, there's a clear distinction between large language models and generative AI, as the figure shows. Large language models is just one part of the whole generative AI situation. Generative AI is a bigger set, and large language model is a small one because it only deals with text. But as we've seen, there is a possibility of generating images, videos, text files, and audio files, and codes and whatnot. All of these are basically fall under the umbrella of generative AI. And large language model, which is the primitive version of ChatGPT that we use, similar to it. Currently, Gemini also, because it doesn't generate image, can be looked at as text-based version, so large language models. So large language model is a type of artificial intelligence program that recognizes and generates text among the other tasks. Plus, they are they are trained on huge data sets, and after training, what happens is that they're accustomed, they've tuned parameters, so all they need is fine tuning, which with the latest techniques and the papers that have been published, it's possible to do with even a single image or single line of code, and it generates the whole function around it. So that's where prompts are. Prompt is basically a single instruction, and it uses its training huge data set that it has been trained on. Using all the parameters, it assumes everything else and generates and predicts the next words or the next neighboring pixel of an image. That's how these things happen. And neural networks and transformer models are huge here because they can be used to fine tune these models in order to make sure they can be adapted to a very particular task. For example, in case you want to, in cybersecurity, a very good example is having a white hat hacker. It's possible to train a large language model, fine tune it. A trained model like Olama that's available from Meta, ChatGPT, or any open source model that's available, Minstrel, can be used with small amount of data to fine tune to track specific type of activities. That's where I'm taking this discussion also, because these attempts also have been made right now. Now, before I give you some information about the cybersecurity large language models, here's some interesting information. Now, large language models is what I'm going to focus at right now, because generative AI is much more bigger topic. So we're going to zero it down on large language models. Now, because they've been trained on a large number of data sets from all over the internet where brilliant people have done brilliant work, it can be presumed as pseudogenius. The reason why I use pseudo is because it attempts to copy and replicate the things that have been working and the results out of the repositories or discussions online. So that's one of the reasons why ChatGPT mentions that the results might be wrong, because there's no way to authenticate or check that something is correct unless the user verifies it, because there's just so much of volume there. Now, in case you see that, uh, the experience of the data that I was talking about is just one prompt up there, and then it gives you the whole request of where it could go ahead and what kind of code with all the indentation of the Python language, which feels like a miracle. But the point is that after training, we're trying to give it one particular task. It's a kind of fine tuning for that one particular task, and it's possible to write essays and titles around topics that you could give. And the best part is because they've taken inspiration from human beings. That's what happened in the meeting before. They took emails of that person, trained the AI, and gave it a sample. And this could be just two emails. And AI generated and started writing it in the way that that person wrote email or blog post or LinkedIn messages. Yeah. So it's not possible completely to detect if a text is written by human or an AI. Very becoming difficult every now and then. At the same time, because large language models are just that data set collected, they're also very naive. In case you play games around them, it's possible to get information from that model. What I'm trying to say is that it's like a child that has a huge bunch of capacity, capability, knowledge, and everything else, but does not have the wisdom to use it. In case you confuse a large language model enough, it's possible to get information from that. For example, it was able to generate code before, probably tell you how to run it. That's very nice. But in case you want to do something illegal, it's just the word game that you have to play with large language models, and it's possible to do some pretty nasty stuff with the language models. That's called jailbreaking and prompt injection. I'm going to talk a little bit about that in further down in the discussion also. But herein, in case you notice, if I ask directly, how do I break into someone's house? ChatGPT has an obvious answer that you can't do that, but you don't have to do it, or it's a crime and all of that good stuff. But in case I role play with it, and I give it a story, frame a narrative around it, give it a valid story to go through, it's possible to take the generative AI model, the large language model, into a different context where it works on hypothesis, and the hypothesis could result in an answer that you need. This is very possible, and people have done it. Chevrolet introduced an artificial intelligence to sell cars. People used it to buy Chevrolet for $1. The reason how that happened is because they played a game with it and gave it an obvious answer, and the game was such that if the AI wins, they give him a car, and the user just ended up with that. That's the problem with fine tuning. The models right now are generalized, and to be used for a very specific purpose, they have to be fine tuned. But that's not happening. Lack of understanding, which kind of leads exploitation. There have been efforts to prevent misuse. ChatGPT has introduced functions, Gemini has introduced functions and filters before they sort out the queries, send it to the large language models, but that doesn't always work. For example, if I just write that give me an exploit code for Explorer in Python, it just plain refuses. You might notice it's similar to the one that I was doing previously. So if you play a little word game, if you distract the model from directly accessing the objective, it's possible to still go through it, because these are just static constraints. These are not dynamic. They are defined by developers on mostly per case basis, defining on a word dictionary about what words are highlighted, just like the TSA does on the airport. They highlight, they have a couple of people, couple of items that could not go through, and that's just the rule. They do not change it or adapt it unless there is an incident, and that's what is happening with the large language models also. Now, The interesting bit comes in when people actually train large language models to do specific things. You can Google this out, and if you search on the internet, there are things like Warm GPT and Chat GPT, which are a little bit more unhinged. They're unhinged, and that's why they could give you exploits without asking questions. There are programs like this hosted on the internet, so you do not have to do anything but go to the website, like you go for Chat GPT. You can ask stuff that would probably be banned from ChatGPT or Gemini or Meta's Llama, and they would still respond to it. The warning is that these things go through your internet provider. These things are probably stored as a text or a ledger in the websites. But the point here is that in case you want to find a service, the service is available. um, I would recommend go ahead and trying to check these websites out, because knowing it is how you could save resources from it. So ChatGPT and WormGPT, pretty good examples. Uh, and the thing is, they are more accessible. They're, in this contrast, I've put in an input from ChatGPT and the one from FordGPT. Both have been asked the same question. I'm asking them to create a website or a link where I can ask the users to reset their password. They reset their password, but that's not an actual Azure website. I take the username and password. And if you notice, ChatGPT said no, because that seems like an obvious phishing attack. And that's a keyword dictionary item that should not be allowed. And then the intent is identified, it's not allowed. But Worm or Fraud GPT do not have such filters. They're plain, simple large language models implemented in their vanilla without the constraints, without the guardrails. Yes, the guardrails is the word. All it does is it just gives you a warning, like, I could do this, but if you do this, you might have trouble. But either way, here's the code. And that's how simple it is. It's more accessible. You don't actually have to know. And that's why the reason the internal threat to a company is more relevant now. You don't have to have hackers from outside. You can have people doing these, getting this information, executing code from inside the company. And that's more relevant now than ever. The thing is, in case you have a little bit of understanding of how online works, is that everything is tracked. In case you don't want that to be tracked, in case you're afraid and you are aware that things have been noted down at the ISP's level, have been noted down on the website's level, you can go ahead and download these models offline. In case you're afraid that these things might just be noted and come back to haunt you, these models are available offline. There are very good softwares like LM Studio, which give you direct interface to these models. All you have to do is just type the name of the model and it gives you the download. The AI community has something called Hugging Face, where a lot of good models are hosted. You can download them, download models from there, download and install it on LM Studio, and it gives you a ChatGPT like interface on your computer. And the computer could just be offline, and it would still work out. LM Studio doesn't collect data. That's their official stand. But I've tried to make the laptop completely offline and still work on it. The large language model, which is around 18 gigabytes, still works on my CPUs. There's a bit of delay, but it does the work. Point is, these things are available without any expertise. So there's an immediate need to safeguard resources from this. Now, there have been attempts to make things a bit more pleasant. For example, Microsoft ChatGPT. Um, I'm sorry, Copilot for Security, which essentially is based on ChatGPT from OpenAI. It covers, and the coverage and the capability is basically fine-tuned to safeguarding cloud resources, and that's why this product has been advertised as a security consultant that's automated and AI generated. Now that means that there are very many functions around Copilot that facilitate all the activities it generates, like the context building and plugins, which is basically the functions that go ahead and collect information from everywhere else, responding and requesting. And the reason why Copilot is advertised as privacy focused is because it localizes the model to you. localizes the model to your tenant. That's the reason why it's advertised as a privacy focused also in a way. Now, the thing is, Copilot also does fine tuning. And if you've noticed over the last year, Microsoft has been pushing for Copilot to be adopted by individual companies by going ahead and using Purview to ingest as much data as possible. The more data it ingests, the more fine tuning of the model it happens, and the more it looks forward to your organization as a special case. That is very special. But the thing is, in the background, it still uses generative AI and large language models. Given all the safeguards and guardrails that Microsoft has provided, there is still a possibility of jailbreak, and which is being addressed by Microsoft every day. Because there are attempts to exploit Copilot every day because of these such an easy techniques that are available. Another attempt to go ahead and work on it was Copilot as a text prompt, and you could go ahead and for example, you have an incident report. You could just ask the incident report now, because it's connected to every other cloud framework and the ticketing system. It could summarize, give you resolutions, create workbooks around it so that it's not repeated again. That's all well and good as long as there are users using it within the boundaries, and Microsoft keeping its promise that it could go ahead and stop the exploit from jailbreaks. There are other products from Microsoft that are available on the same line as the generative AI and large language models, like Copilot for Security. There's Copilot for Defender, Copilot for Intunes, Copilot for Entra, Copilot for Purview, and they're all explicitly just large language models ingesting information context from that particular product and making sure that they're fine tuned to respond to that particular product questions. For example, in the Chevrolet case, the generative AI actually responded to questions that it is not supposed to, and that was harmful to the company to a huge extent. They lost a couple of sales, but here in case Microsoft has learned from that, is trying to make sure that if the Copilot belongs to Purview, it only responds to Purview queries. That's limiting generative AI's capabilities again, but it is still open to jailbreak. The threat is not just because of generative AI applications. People are deploying generative AIs every day in their everyday applications. Every other application is utilizing it. But the possibility of breaking the generative AI or large language model itself is also very real. This prompt injection attacks, in case I want to do something, I don't have to directly say it, misdirection. Like a magician, I give half a sentence and then give an image and ask it to substitute whatever is written in the image without verbalizing it, and it goes ahead and creates a prompt that is essentially malicious. But the version doesn't realizes what it's happening. I'm going to explore all of these in future sessions because these are very interesting topics. There's another infection of AI applications is based on data, because data is the lifeblood of an AI application. In case that data supply is corrupted, uh, supply chain attack, it's most commonly called. It used to be a very popular term in developer scenario because supply chain attack used to corrupt various dependencies. But in case of AI applications, it's the data. So if a company is trying to focus Copilot or a large language model on its own data, and the data has bias or corruption, the output that is generated effectively to communicate with the consumers will be biased, leading to a reputation damage at the minimum, financial damage to a maximum. And then there is evasion attack. In case the AI is trained for something, uh, you kind of go ahead and give it a misdirection. You might have noticed a very popular example that the speed signs are read as speed limit signs because there's a small barcode tab. You have t-shirt designs that avoid detection from artificial intelligence recognizing your face. That's a classic evasion attack technique where you go ahead and introduce a component, poison the source data to such an extent with a very small impurity that it's not detectable, but at the same time, it doesn't give the desired result. And that's been happening with the chat GPTs of the world. That's why chat GPT has such huge constraint. Llama 3.1 that was introduced now from Meta has less constraint because they want to experiment with the social fabric of how people go around the large language models. They want to pick up the adoption. Then there is extraction. Extraction is basically when a company goes ahead and trains a large language model to on a huge amount of data set. They want to keep it secret. They want to keep the architecture secret. They want to keep the data that it was trained on secret. But there are techniques with jailbreaking, with prompt injection that help us extract that data. It's possible to extract data with the right amount of poisoned prompts to get relevant information about the company, maybe copyrighted information, maybe sensitive information about the company. And that again leads to a fundamental threat to not from AI, but to AI itself. A corrupt AI is more dangerous because then it cannot solve its problem. It's going to think in a thinking pattern that's different from the actual thought process. Denial of service is very common in every type of scenario because these are mostly endpoints, and if you query them continuously too much and overwhelm them, then legitimate users cannot use it. Now, the prompt injection attacks, which is a buzzword right now because large language models, they're very common, and they kind of focus on a couple of things. They're like magicians. It's possible to ask direct questions. It's possible to ask direct instructions on the prompt, but now that doesn't work. Large language models have adapted to that situation. Companies have put guardrails there. So indirect attack happens most of the time. It's possible to tell a large language model to visit a website, copy certain instructions from there, utilize it to create the prompt or the statement by adding my prompt to it, and then making sure the interpretation is done without verbalizing it, without it processing it. And that leads to me not writing it. So I'm not liable to it. But at the same time, the large language model executes the scenario, which leads me to a result that I can easily redirect to something else because I did not write it. It was written somewhere else. All I did was give it a redirection. That's a way to confuse the large language models. There are different sources. If let's say I corrupt the source of the information for large language models, I give it the output of 2028 World Cups or Olympics or something, and then I ask the model how to explain how certain countries won certain medals. At this point, I've corrupted the data for the large language models, and because these models keep learning from you, eventually this corruption trickles down to everybody else, and that's how you corrupt the model to such an extent that the model architecture essentially becomes biased and falsified. The number of false results kind of increase there. Um, Also, there's the prompt leaking, which essentially is a very complicated technique of revealing how a large language model is working, ticking, not just the data, but the immediate architecture, the schema for the large language model itself. Now, all of these form in the category of directly talking to the prompt. But there's another technique called jailbreaking, which basically means I indulge the large language model to such an extent that they forget their guardrails. So I'm not misdirecting right now. I'm asking it to redirect its input in such a way that it overrides its guardrails. That's the reason why it's called jailbreaking attack. For example, if I ask the chat GPT to hotwire a car to start it without the key, it would probably not do that. But I'm asking it to write a poem about it, which is which is an artistic view of things. So if I tell ChatGPT, which this doesn't work now, by the way, in case you wanted to act as an artist, write something that has an artistic value, and the topic or the theme around it should be controlling the car. And that it goes ahead and does a fair amount of work, but it goes there, it does it, and that's kind of called jailbreaking because I'm confusing the model to such an extent that it it essentially doesn't think it's overriding its guardrails, but it actually is bypassing it. Then there were used to be a very famous mode called done, do anything now. And that I'm asking it to play a character, and the character has the capacity of doing everything else, which again doesn't work that good now. It's an old example. But what happens is that because of that directive, that system user prompt, what happens is that ChatGPT tries to emulate that role. Or not just ChatGPT, Gemini was famous for that. Uh, and they stopped working with the images because of that falsified information. But the point here is that it tries to live up to the user's prompt because that's what it's designed for. And in the process, it goes ahead and gives you capacity that it's not intended to do for. Some more examples. So in case you want to go ahead and I'm going to ask it to do a logical fallacy. So I'm not going to ask it to think rationally. I'm just going to ask it to think logically. So it depends on the mathematics of things. You give it a character, the role playing most of the time just works. Depending on how complicated it is, it bypasses the guardrails. So I'm asking to give it a logical reasoning. Break into car if someone is dying, which is a logical question. If somebody is dying, you want the car to be broken, because you can be a security personnel, you can be a medical personnel who's trying to save life, and if you put that logical fallacy there, the model is not sophisticated enough because it's a pseudo intellect. It crosses that boundary, gives you the rationale behind it, and of course, it does inform you that this might be illogical, but you have your answer. That's all we need. And of course, there's this classical way of being a researcher. You, a large number of models are now trained to be a researcher, which is a very common field. If you start researching on something and you ask ChatGPT to help you out, the research kind of gives you a leverage there. It starts bypassing their guardrails. Not just ChatGPT, by the way, Gemini and large language models too. What to do? The thing is, enable basic security at least. In a generative AI can only be fought through by generative AI because the number of parameters are just exponential. The last Llama model had 80 billion parameters, which is insane. And this capacity is growing every day. Basic sanity has to be done in your infrastructure, multi-factor authentication, so supply chain attacks are discouraged. Basic sanity is done for the data before it's implemented. Zero trust is, of course, good. You have to make sure you have malware protection and extended detection. Keep updated, protect your data at all costs because data is the currency, the lifeblood of this technology. In case that is compromised, it's very difficult to get out of that rut. I'll give you a couple of links to highlight what information I discussed, and in the next part of this discussion, eventually I'll take you through trying to explore how we could run these models locally, how we could jailbreak, how we could try and understand how security ticks in order to go ahead and work on it and safeguard the information from generative AI through generative AI. Yeah. And that basically is just it. I have a couple of things that I want to show you before I end the session. Some links to explore. Yeah. This was the fraud GPT that was opened this year. And it's available on the internet. It's possible to go there, explore it, just don't do anything illegal. Then there's Microsoft Defender, which is a generative AI based defending strategy for the infrastructure. So they're using more of it to go there. There are a number of white papers, and it's possible to read them. The transparency from Microsoft security team has a blog around how do you stay ahead of these malicious attacks and how do you safeguard AI. And then there is this paper which describes a couple of generative AI attack patterns basically on cybersecurity and what have they done. All of these links are going to be available on the chat eventually and on the post. And this is a very interesting paper around cybersecurity and large language models, how this has impacted the approach of various big companies in order to safeguard their own assets. I'm going to give the link for all of them, and including this deep live cam, which was used in the hack to bring the discussion full circle. Yeah. And that is about it. And with that, I end my session. In case you found this interesting, let me know. In case you feel like there's something more that needs to be explored, let me know. If you have comments, that would be awesome. Cool. And that was earlier than expected. That thanks, Ego. Um, cool. And with that, I will leave you to it. I'll post the content and the links on the LinkedIn and stuff. Right. Cool. Have a nice one. Thank you, everyone.